Today I am going to discuss about linear regression and least square regression. Here first I am taking one problem and then I will talk about the theory behind it, and then I will solve by hand as well as I will solve in MATLAB and Excel. So here the problem is the following data are gathered to determine the relationship between the pressure and temperature of a fixed volume of 1 kg of nitrogen, and the volume is given, so that is 10 meter cube, and temperature and pressure data are given. Temperature in degree centigrade, pressure is Newton per meter square. Employ the ideal gas law PV is equal to nRT to determine R on the basis of this data. Means we have to calculate R by using this data. Note that for the law T must be expressed in Kelvin. So here T is in degree centigrade, but when we employ that ideal gas law, T must be in Kelvin. And question number A is calculate R from, again we have to calculate R from the linear fit by a least square technique in MATLAB and Excel, and then plot T versus P. Calculate R from polyfit. So here polyfit is the MATLAB inbuilt function. Using that inbuilt function, again we'll calculate, means again by using polyfit, again we'll calculate R and then again plot T versus P, and finally calculate P at temperature T at 100 degrees centigrade. Okay, so at 100 degrees centigrade what will be the P values? Means after getting the R, so we will put in the ideal gas law, and then at particular temperature what will be the pressure. So that we have to calculate, and that is the question number C. Now I am talking about least square technique theory. So least square regression theory. So the least square method for linear data fitting. Linear data fitting is a technique used to find the best fitting state line that minimize the sum of the square difference between observed data, so observed data points, and their corresponding predicted values on the line, right? This method is commonly employed in a linear regression line. Suppose you have x and y data, right? So these are suppose x and y data. Now if we feed that data, means suppose if we get or we fitting the data in a straight line. Suppose this is the straight line. Okay, now if we take so this is that observed data point, and in particular x, suppose so if we go to that x that straight line, so we'll get another data, right? So that is y data. Okay, so that is the predicted value. Okay, so from predicted value and observed value, obviously there will be some error. So our target is we must get such straight line so that error should be minimum. Now how do you do that? How do you get that straight line? Let's consider a set of data points, so that x and y data points, so that are given. That is actually observed data point or sample data point, where I is equal to 1 to n, and we want to find the equation of straight line, because here, so we have to find that straight line. The best represent the relationship between x and y. So so these are the data point. Okay, so we are trying to get the straight line, so that will best represent the relationship between x and y, and the equation of the straight line is typically represented yp is equal to a1x plus a0, where a1 is the slope and a0 is the y-intercept. Y is the predicted dependent variable. Now we already know the error between the two data of the corresponding variable is ei. Ei is the error. Ei is equal to yit, that is true value, or that observed data point minus yip, so that is predicted data point. So after getting that straight line equation, we can easily get that yip. Our target is to minimize that error. If we get such straight line where that error is minimum, so that is our target. So that will be the best fit straight line. Now how do we get that? Now we already get the error. So ei is equal to y observed data point minus that predicted data point. Now if I take the sum of So here we already get, so if we take the error from observed data point to predicted data point, so that is EI. Now if I take the error sum of that, the error, so EI is the error. Now if I take the sum of all the error, now first if we square that error, okay, so we'll get the error, okay, YIT minus YIP, and then we took that sum of the all these data points error, right? Now here we are doing that next slide. So here sum of the square of the error of all data given by SR. SR is summation of ER error square I to n. So that we can write YIT minus YIP square. And Y predicted, so we took that straight line equation. So A1 xi plus A0. So we just plug this YIP. So YI minus A1 xi minus A0. Now here, so this is the straight line equation. Our target is that find out A1 and A0. Okay. So after getting A1 A0, so we can get that straight line, and if we plot that, so that will give the minimum error. So now if we plug that YIP, so we'll get SR. SR means sum of the square of the error. Okay, so that is summation of 1 to n ER square is equal to YI minus A1 xi minus A0 square. Now to minimize the sum of the square, means if we want to minimize that, okay, so partial derivative with respect to A1 and A0 will be 0. Now if I take the partial derivative, dou SR by dou A0, so that will be 0, dou SR by dou A1, so that will be 0. Now if I do that, okay, so first we have to take the partial derivative. Okay, so partial derivative, we'll get the equation. So two equation we'll get, and from that we can easily get A1 and 0. Now how to do that? How will I do that? So I'll explain in that this slide. So now here we are doing that partial derivative, dou SR by A0. So that will give, now if we go back here, so if we do that partial derivative, okay, so this is the equation. So that if we do that, so if we do that partial derivative with respect to A0, so first that because of square, that 2 will come, and then this will come. Summation obviously will be there. So YI minus A1 xi minus A0. So because of the square. Now here this is independent variable. So this is also independent variable. For partial derivative, this will be 0, this will be 0. Now if we do the partial derivative, dou A0 by dou A0, so that will give minus 1. Okay, so ultimately we will get here summation minus 2 summation of I is equal to 1 to n yi minus A1 xi minus A0 is equal to 0. Now similarly, if we do the partial derivative with respect to A1, dou SR by, so this is dou will be there, dou will be there, dou A0 by dou A1 minus 2 summation of I is equal to 1 to n yi minus A1 xi minus A0. So here if we do that partial derivative, so that with respect to A1, so minus xi term will come. Now so this is the equation number 1, minus 2 summation of I is equal to 1 to n yi minus A1 xi minus A0 is equal to 0. Another equation we get, so that is minus 2 I is equal to 1 to n yi minus A1 xi minus A0 into minus xi is equal to 0. Now from the equation 1, if we reorganize, so ultimately we will get, so summation I is equal to 1 to n yi, okay, and then AY will be coming out, summation of I is equal to 1 to n xi, and then minus summation of I is equal to 1 to n A0 is equal to 0. Now from here to here we will get, we reorganize, so if we take these and this one side and this one is other side, so ultimately we will get A1 summation of I is equal to 1 to n xi plus n A0, because that n data point, so every time so 1 will be added, so n into A0 is equal to I is equal to 1 to n yi. So this is the equation number 1, and similarly equation number 2, okay, so 2 will be vanish out, minus will be vanish because if we do the multiplication with 0. then I is equal to 1 to n yi minus a1 xi minus a0 into xi. So if we multiply, so yi xi a1 xi square, then minus a0 xi. Now this term and this term, if we take that left hand side, so that a0 xi, I is equal to 1, so this term will be here and this term will be here. A1 summation of I is equal to 1 to n xi square is equal to summation of yi xy. Okay, now ultimately, so two equation we will get. Okay, now here, so a1 and a0 are the unknown. Okay, so we have to find out a0 and a1. Now if we write in the matrix form, so x, I, these data actually are known. These data are known. If we write in the matrix form, so that will be that n will be the coefficient of a0, then coefficient of this will be here, summation of I n xi, summation of I is equal to 1 xi, and summation of I is equal to 1 to n xi square. So these are the coefficient matrix A. Okay, and a0 a1 is the unknown, so that x, and this is b is the right hand side, that is I is equal to 1 to n yi, and I is equal to 1 to n yi and xi. So we will have that matrix form Ax is equal to b. Now if we solve this matrix, right, x will be A inverse b, we will get a0 and a1. Okay, so that we can do, if we do that, x is equal to A inverse b, we will get a0 and a1. So if we get that a0 and a1, so we can get the predicted straight line, so that yip is equal to a1x plus a0. So that will get the straight line, and if after getting that straight line, or after getting that equation, we can get any y value with that known, or if we want to get y value of any x, we can get from this equation. Now I'm going to solve this problem by hand. So how to implement that least square technique to get to solve this problem. So now in this problem, we have to determine the R, right? So now here ideal gas law is PV is equal to nRT, right? So now here T and P data are given. Now you can write that P is equal to nR by V by T. Okay, and this above equation, this equation we can write that yp is equal to a1x a0, right? So this is yp is equal to a1 that x plus a0. Now here a0 is actually a0 is 0. Okay, so it is like a y is equal to mx, the equation. So m is the slope is here is a1. Okay, so here we have to find out a1. After getting a1, then we can easily find out r. Now we are going to implement least square technique. Okay, so here again, so that we can write that p is equal to a1x plus a0, the straight line equation. So where yp is represented as a p. Okay, so and x is represented as a t, and a1, that is the slope, is nr by v, and a0 is actually 0 here. But when we calculate, we will use the least square technique, so we will get some value, so that we can neglect it. Now how do you get that? So we have this matrix form. Okay, so first we have to calculate all these values, right? Now here, so p as that yp is represented as a p and x is represented as a t. Now here T and P's data are given, so the T is in degree centigrade. Now that we have to calculate in Kelvin. So now we have to add T plus 273. So that is the X data. So minus 40 plus 273, so 233. So we are getting that the T data. So that is actually X data, and P data are actually Y data. So now we have X data and Y data. So now here we are calculating. Because getting that matrix, so we need summation of x square, summation of xi, sum of x, sum of y. So these are the data. Sum is that 1998, and sum of y is 59350. Sum of x square means that 233 into 233, we'll get that x square. Now if we do the sum, so we'll get 693334, and sum of xy, so that will be huge number 2059250. Now if we form the matrix, right, so we know, so this is the matrix form, so we have all this data. Now if we write in the matrix form, so that will be the matrix form. So we have the 6 data, so here n is actually 6, so 1 2 3 4 5 6 data, so n is 6, and then summation of x, summation of y, everything is given. So summation of that x is 1998, okay, and that is also summation of x, okay, summation of x data, and summation of x square data, and summation of y square data, summation of xy data. Now so this is the matrix, so this is A, this is x, and this is B. Now if we do A inverse B, you can easily calculate by that hand calculator. We can easily do it by hand calculation, or we can use calculator, we will get that. So here if we do A inverse B, so A0 will be 32.48809.524, and A1 will be 29.607.14286. okay, so now we know that yp is equal to A1x plus A0. Now if you plug that A1 value, so that is 29.607.14286x plus 32.4889524, right? So this is the intercept. Now if you compare, so that is y intercept. If you compare with that y data, okay, so these are y data, so that values are very small, because y data are very large compared to A0 value. Okay, so that we can neglect it. Now A1, so we know that P is equal to NR by V by T, so that is YP, and is equal to A1, so A1 into X. So A1 is NR by V, so that is 29.60714.286. Now so NR is actually NR by V is equal to 29.60714.286. So that is we got from the least square technique. Now data given here, the mass of nitrogen is given 1 kg and volume is given 10 meter cube, right? So mass and volume is given. So volume is given, so that is number of moles. So we have to calculate how many number of moles of nitrogen is there. So the molecular weight of nitrogen we know, so that is 28 kg per kg mole. Now 1 kg mass is given, so we can easily calculate number of moles of nitrogen. So 1 kg by 28, so that is 0.0357 kg mole. Now we have to look about the unit. Okay, based on that unit we can calculate what will be the R. So okay, R depend on the unit, right? Now here we are taking that N is a kg mole, so now we can take in a gram mole, so that is 35.7 gram mole, right? So that is 0.0357 kg mole. So we can write that if we convert kg mole to gram mole, so that will be 35.7 gram mole. Now volume is given, so R we can write, so NR by V is equal to 29.607, so R will be 29.607, so NR by V is actually given 29.60714.286, right? So R will be 29 into 60714.286 into V by N, so N is 35.7, V is 10. Okay, so if we calculate, so I will get R value is 8.293317. Now if we check the unit, so that R value will be 8.293317 Pascal meter cube gram mole Kelvin. So Pascal is, you know, Newton per meter square. So Newton per meter square meter cube gram mole Kelvin. So that I am showing hand calculation how to calculate R. First I use least square technique. By using least square technique I am getting that best straight line, and from the straight line we calculate that A1 A0. From that A1 is nothing but NR by V, and from there I am calculating R. So R here from this data T and P data I am getting R is equal to 8.293317 Pascal meter cube gram mole Kelvin. So that is the hand calculation. Now I will show how to solve this problem in Excel as well as MATLAB as well as polyfitting will function, and again we will calculate R. Okay, and then we will plot T versus P by using that best fit straight line equation. Okay, so I'll show it in that Excel, and then I'll go to the MATLAB.